Hi everyone. So today we are going to talk about a new operation for polynomials, and that is dividing them using long division. So long division is probably a process that you remember learning in, I don't know, maybe fourth grade, third grade. I forget when it shows up first. But here's just a really simple reminder of what a long division problem would look like. So if you needed to do 65 divided by 5, you would set up your long division by putting the divisor, what you're dividing by, out here. You would put your dividend, that's what you're dividing into, kind of underneath here. And then you'd go through a process to figure out how many times 5 goes into 65. So basically you say to yourself, okay, 5 times what number is as close as possible to 6? So 5 times 1 is as close as possible to 6 without going over. So we do 5 times 1, and we write that here. We subtract those numbers, we get 1, and then we bring the 5 down. And then we repeat the process. So 5 times what is as close to 15? Well, 5 times 3 is actually exactly 15. So we choose to put a 3 up here, and we do 3 times 5 is 15, and then we again subtract those. Once we can't go anymore, once we have no more numbers in our dividend, we would stop. And in this case, we would stop at 0. So that means we have a remainder of 0. The answer to our division problem is called a quotient. So we are going to do this exact same process, except we are going to do this with polynomials. So again, the algorithm is the same. It's just that we're doing this with polynomials instead of integers. Okay, so we want to do the result when that cubic is divided by x plus 1. So first of all, I'm going to set this up in the same way they would set up a long division problem with integers. And I'm going to really focus on the x term, not the 1 term. I'm going to focus on the term with the highest exponent, the leading term, when I go to think about, how many times does this go in evenly, or what do I need to multiply by to get close to the 2x to the third? So I basically say to myself, let's focus on these 3 terms. And let's say, okay, x times what gets close to 2x to the third? Well, x times 2x squared is actually exactly 2x to the third. So I'm going to choose to put a 2x squared up here, because when I multiply it by x, I get exactly 2x to the third. So I'm going to put the 2x squared up here, and then I'm going to multiply it by x, but I'm actually also going to multiply it by the 1. And I'm going to put the result in the next line. Okay, and then we're going to subtract just in the same way that we subtracted with integers. So just, be a little bit careful here. You're going to subtract both of these terms. So 2x to the third minus 2x to the third is 0. That's gone. That was kind of the goal. But then 9x squared minus 2x squared is going to be a 7x squared. So we just want to be careful there that we make sure that we are subtracting what we have here. And then the other 2 numbers I'm just going to bring down. So the 17x and the 10 just come down. Now I'm going to repeat this process over again, focusing really just on the x for now. And x times what will get us to 7x squared? Well, that would be a 7x. 7x times x gets us 7x squared. So what we're going to do is multiply the 7x times x, but then also the 7x times 1, and we're going to get the result. That goes here. So 7x times x is 7x squared, 7x times 1 is 7x, and we're going to subtract, again, just like the traditional division algorithm. These will cancel. That was the point. And again, remember, you're subtracting. So 17x minus 7x gets us a 10x, and I will bring the 10 down. We're going to do this, we're going to keep going until we can't do this anymore. So now I'm going to say, okay, x times what will get us 10x? Well, that would be a 10. So 10 times x gets us 10x, and then we're going to also multiply the 10 times 1. So in this case, we get 10x plus 10. I'm going to subtract one more time, and 10x minus 10x is 0, and actually 10 minus 10 is also 0. So I'm going to end with a remainder of 0. So in this case, we've ended with a remainder of 0, and our quotient is what we see up here, the 2x squared plus 7x plus 10. So we've actually found something that divides evenly, okay? So we can use the same phrasing that we use for integers. It looks like x plus 1 is a factor of this cubic, since the remainder is 0. Just like on the previous screen, we would have said that 5 is a factor of 65 because it goes in evenly, right? It went in 13 times. All right, let's have you try one. Okay, so you guys are gonna do this division problem. So you will need to pause the video, complete this division problem on your own on some paper. And then when you're ready, you can unpause the video and check your work. Okay, so if you're back, you hopefully have completed this problem. Let's go through it and let's see, kind of how we did and if there are any things we need to talk about. So this one's a little bit different. We're dividing this quadratic by a cubic. So the first thing that I need to think about, and back up for a second, is, what do I multiply x squared by to get 2x to the third power? So 2x times what is 2x to the third power? That's what goes here. So that would have to be a 2x, right? 2x times x squared will get us 2x to the third. So that is my choice for the first part of my quotient. Now I'm going to multiply that 2x by both and put that in the next line. Now, I like to make sure that I'm lining up like terms, right? So 2x times x squared is 2x to the third. That goes underneath the cubic term. 2x times 1 is just 2x. So I'm just going to line that up underneath the linear term. And then I'm going to subtract. So keep in mind, I'm subtracting. So 2x to the third minus 2x to the third is nothing. And then I'm going to have an x minus 2x, which is going to get me a negative x here. The 5x squared and the negative 5 are just going to come straight down. So I've got the 5x squared that came straight down. I've got the x minus 2x that became a negative x. And I've got the negative 5 that came straight down. Okay, it's kind of like you're subtracting the zeros in here. All right, now we're going to start the process over again. X squared times what will get us 5x squared? Well, that's just a 5. Now we're going to multiply both of these terms by 5. And again, I'm going to line them up correctly underneath their like terms. So 5 times x squared is 5x squared. 5 times 1 is 5. And now I'm going to subtract. Okay, so again, it's kind of like we have a 0 in here. So these will subtract to nothing. Negative x subtracted by 0 is still just a negative x. And then negative 5 minus 5 is going to be a negative 10. Okay, so now I'm going to hit a point where I say, okay, wait a second. I've got to do x squared times something to get x. That doesn't make sense. I can't start at an x squared, multiply by something, and go back down to an x. That doesn't make any sense. So if I've reached a point where we can't go any further, we have a remainder. Okay, so our remainder should have a lower degree than what we're dividing by, than our divisor, right? Because again, I can't think of something to multiply x squared by to then get an x. Certainly, I can't think of a polynomial to multiply that by. So if I'm at that point where I have this, expression here that's a lower degree than my divisor, I can stop. That means I have a remainder. So I can write this in a couple different ways. I can write it, kind of the way that you would write an integer division problem when you were in 3rd or 4th grade with the quotient and then just write what the remainder is. But the better way to write this is kind of as one expression of both the quotient and then also the remainder over the divisor. So this would be like if you divided, an integer into some number that didn't go in evenly. So the original problem we did was 5 into 65. That went in evenly. But if we did 5 into 66 instead, we'd have a remainder of 1. So you could say the remainder is 1, but you would also be able to write that as 13 and 1/5. You would say it's the remainder over the divisor. So that would be a 1/5. This is a similar idea where we're taking the quotient and we're going to say remainder over divisor. Okay, and I actually prefer this answer because it's a full expression of what the result once you divide these two polynomials is. Okay, so when you're doing practice, this is kind of the preferred answer, but both of these are, kind of an acceptable way of expressing your result. Okay, so just like a quick vocabulary recap, because it's important that we can refer to all of these terms in the appropriate way. So again, the number that you're dividing into is called the dividend. Okay, so that is the number kind of underneath your division sign. It's what you're dividing into. If you write your division as a fraction, it would be the numerator. It would be the polynomial on top. The divisor is what you're dividing by. Again, if you wrote your division problem as a fraction, this would be the denominator. This would be the bottom of your fraction. The quotient is the answer that you get after division, ignoring the remainder, just the answer that you get after division. And then the remainder, again, is whatever you get that is left over. When you go to write your answer, okay, again, in the kind of preferred method here, in the preferred format, you would write your quotient first. So that's q of x, q for quotient, and then add it to the remainder over the divisor. Okay, so r of x is the remainder polynomial, and b of x is your divisor polynomial. There are a lot of examples on Delta Math and things like that that ask you to write your answer in this format. So again, this is kind of the preferred format. Thank you for listening.